Now let's finish off the videos on subroutines. On the left, I have the same file that we used in the very last video. Now, I'm going to take a copy of this and I'm going to pass it into the file on the right. So the file on the right is going to be the subroutine call. So we're going to call the subroutine. The file on the left will be the actual subroutine. It will run through and then we'll return the value back to the calling function. Now we're doing this because we want to split the subroutine up. We don't want the subroutine to be actually within the calling function code. Our subroutine, we want to put it into the ROM. So for example, if we had a print screen function, and let's say it's about 40 or 50 lines long, then every time we wanted to print something to the screen, we don't want to have to write out 40 lines of code, or we don't want to have to go and get it and attach it every time. So what we want to do is just save this piece of code somewhere in the ROM. Now in this instance, the print character and the get character is going to be held in an area of the ROM which we call the BIOS. That's the basic I/O system. So we want to be able to save the actual subroutines in the ROM, and we want to have the calling function in the RAM. And that's why we've split it up like this. So let's say, for instance, we're going to start off here with the calling function. So it doesn't matter where we start it in memory. We're going to start it as usual in 0x8000. Now, another thing that we're going to do is, if we noted in the last example, we put the values that we want to put into the subroutine in the registers, so that the subroutine would know the values were in the registers, and it would return another value to the register, and the calling function would know it could get the result from a register as well. So in effect, we're transferring the variables via the registers into the subroutine, and we're transferring them back like that. Now we can do this, but my preferred option is to pass the variables in using the stack. And that's how we're going to do it through the other libraries of functions which I have already generated. So let's say, for example, in this case here, we're going to have first and second. So what we can do is we can push the first onto the stack. Now again, there's a couple of different ways we could do it. We could push the address of first, which is the actual variable, or we could push the value. So that's two different ways of passing the information into the subroutine. So we can pass the information by value, which is what we've got here. Or if we take the bracket away, we can pass the information to the subroutine by reference. So that is, we're referencing the value indirectly from the actual variable. Okay, so that's two different ways of passing, by value and by reference. So let's do it by value. So we'll need to get the other one, which is the second. So we'll go push and second. So we know first and second are on the stack, so first goes in and then second goes in. And then we're going to jump to subroutine add underscore num. Now the subroutine add underscore num is over here. And the question is then, whereabouts over here? Well, it has to be somewhere in memory. So we have to set aside a location within the ROM to save this subroutine. So this is why we generate a memory map, because we have to keep track of where all of the subroutines are. And not only that, we have to keep track of exactly how we pass the variables into the subroutine. So in this instance here, we're going to add two numbers. So it doesn't really matter whether you pass the first and then the second, or the second and the first. But other routines, subroutines, it might be very important that you pass the values in a certain order. And this is something that you have to at some point write up as part of a library of subroutines, and you have to show how you pass the variables in and out of subroutines and whereabouts the subroutines are held in memory, and a few other bits of information. But we don't need to get into that detail here. We just want to get the thing up and working in under 15 minutes, hopefully. So we jump to the subroutine add num. So whereabouts is that subroutine? Well, we could give it a actual place in memory. So we could say EQU, and we could put in add underscore num, and add underscore num would be a memory location. So let's just say, for instance, we'll just work in some random memory location just for an example. So it would be something like 0 cross, and let's put in 0500. Okay, so that's a memory location for the subroutine add num. So everywhere it sees add num up here, it just goes in and replaces it with this here. Okay, so it doesn't jump to here to get the this function. The subroutine is going to jump over here. So this point over here is going to have to be 0 cross 0500. So this is where this subroutine is actually starting. So we get to this point here, and then it jumps over to here. So this stuff here, we can say Control X, and we'll put it over here for a moment somewhere. So it's going to be in here, Control V. Now, once we've worked through this subroutine, we want to return the result. So the way we're going to return the result is we're going to put the result onto the stack. And when the result is on the stack, we can return back up to the calling function. So in order to get the answer, we can just pop the answer back straight off the stack. So I can put in pop, and we're going to pop it into answer. Okay, so it means that we've got the result, and we can put that result straight into the memory location called answer. Now again, this isn't going to go here because the return address isn't here, but we are going to have the first, second, and the answer. Now that's us really covered the calling function, and I can just put an end in here. Okay, so that's the end of the program. So the calling function is quite straightforward. We can see the route that we're going to take. So now that we've worked the calling function out, let's go into the subroutine. So the subroutine, we're not going to need any of these here, but we are going to need the return address, because whenever we come in here, we're going to take these away. We're going to have that's going to go, that's going to go. So we jump into this subroutine, and the first thing we do is we know that we've put first on the stack, we put second on the stack, and then when we jump to the subroutine, the return address is going to be at the top of the stack. So what we're going to have to do is pop off the return address. Okay, so now the return address is popped off, we need to get access to second and first. So we could pop the next one, so into register R0, and we could pop the next one into register R1. Okay, so in effect register R0 is going to contain second, and register R1 is going to contain the number first. Then we can add both of these together. So then if they've been added together, we then add them together, and then we can get the answer, and we can push the answer back onto the onto the stack. You can see how complicated this gets trying to explain it. So we can pop the answer. So the answer's in register R1. So we can push the answer. So we can push the answer on to push R1. So the answer goes on to the stack. So now the answer is on the stack. We can jump to this return address. So let's get rid of all of this here. Okay, and we can jump to the return address. So the return address here is the value here, which is has been placed onto the stack. So in fact, the value of the return address has been saved in this memory location here. But of course, we have to be careful here because we're not going to save it in these memory locations. We could save it in a different memory location that we need to save it in a different memory location from here, because these memory locations are already taken up with the calling function. So we need to have a memory location for the actual subroutine. So we could maybe say, again, it has to be in the RAM because we can't write into the ROM. So the temporary or the local value for the return address in the subroutine has still got to be held in the RAM. So we could, let's say it was 0 cross 8 or 9000. Okay, so that's where we're going to hold this. And again, we would have to take note of all these positions where we're holding the memory locations, because we don't want to write over them with some other piece of code. So let's have a look and see if we can save this. We'll run the file and we'll assemble it and see whether it actually works. So let's just see if we get any issues. And that one has actually worked. It says assemble successful. And if we went into this one here, we could do the same. We could go run terminal, run task, assemble. And again, that's assembly successful as well. Now I'm not going to run these for the moment because the values that I've put in here for the actual positions within the ROM are just made up. And in fact, what I would have to do is I would have to take this piece of code. I would have to, now we've generated the machine code, I'd have to take the machine code and I would have to position it at this correct position here within the RAM. So I'd have the ROM, I would have to load this into the ROM at that position. So that whenever we run this, it would be quite obvious and straightforward what it does. We come down here, we push the first, push the second, we jump to the subroutine. When we get into the subroutine, we first of all take off the return address because that's the top of the stack. We take off the first and the second, and then we into register R0, R1, we add them together, and then we push the result onto the stack. So we push register R1, and then we can jump to the return address again. So we jump back up to here, and when we jumped up here, we can pop the value off of the stack and we can place it into answer, which is here. And that's the end of our process. Now there is one other thing that we're going to take care of before we go any further. And that is that whenever we come into this subroutine, we have to be careful that we, in effect, the subroutine, when we run the subroutine, we save the original values of the registers somewhere, okay? And then whenever we've come out of the subroutine and it's finished, we can restore those values into the register. Otherwise, potentially we could end up writing over the registers, and whenever we write over the registers and return back to the calling function may need the original values that were in those registers, and we've written over them in the subroutine, and we don't want to do that. So in effect, kind of the subroutine has to run without and replace everything back to the way it was. So it takes the register values out, it runs, and it places the register values back in, and it's almost like it hasn't been there. Okay, you don't notice it's been there. So in order to do that, we're going to notice that we'd use register R0 and register R1. So just for safety, what we can do is we can store the value, store R0 in a memory location. So the memory location can be, so we could call it R0 TMP, and then we could store R1 in R1 TMP. So we've taken the original values and we've stuck them in a memory location, and then just before we return back to the calling function, we can restore the values back in. So we can then load the value R0 TMP into register R0, and we can load R1 TMP into register R1. But of course we have to declare these down here, so we can say DC, and we'll say R0 TMP, and we'll initialize it with a value of 0, and then we're going to have DC R1 TMP, and we'll initialize that one again with a value of #0. So that's us generated a nice little route to creating a subroutine, and we're able to pass the value into the subroutine. So just one other thing before we go, I promise, and that is that I mentioned that we can pass the actual value in, or the reference. So we're passing the value, we're actually passing number 5 and number 3 into this subroutine, and we're running it with those values. But if we wanted to, we could pass in like this here. So we could pass in the actual variable, which is just the address where we hold this number. So we could pass in 8500 and 8501 in here. But of course, whenever we pass those values in, if we want access to the actual value, we're going to have to load the value into the register. So if we use the load command, it will load the actual value that's held in that memory location, and we'll have to do that for both of those values, first and second, and that would be an extra line of 2 lines of code within here, but that would allow us to pass in the actual variables as opposed to the value. And sometimes that's useful because you want access to the variable as well as the value whenever you're running a subroutine, and sometimes it's handy to pass them in like that. So this has been quite a difficult video. I think the best thing for us to do is for me to produce just one more video where we can run through an actual example, and I've got I pick out an example of something that I've already built, and it's already within the machine, okay? And the thing is, I've written about, I don't know, 30 or 40 of these so far, okay? So I'm quite used to seeing them, and it seems quite straightforward. But that's enough for this video. I'll get you on the next video, and I promise we'll finish off with this, and see after that, it's plain sailing from here on in. So thank you for listening. I'll get you in the next video. Goodbye.